Hello student, welcome to this lab of electrical machine. Today we are going to start the very first experiment, that is on the transformer. Now the topic of our experiment is voltage regulation and efficiency of a single phase transformer. Okay, so first of all we are using a single phase transformer, that is I have already cleared in the theory class that in general we use two types of transformer, one is single phase and another is three phase. But here we are using single phase, that is there will be one phase and there will be one neutral. And what we are finding? We are finding voltage regulation. I will give you the definition of that also, and we are also finding the efficiency of that transformer. Now to proceed with the experiment, first of all we have to draw the circuit diagram. The circuit diagram is in front of you. You can see this is the circuit diagram. Okay, what is there in the circuit? Let us discuss. This is the schematic diagram of auto transformer. So for what purpose auto transformer is being used? It is used to provide variable DC, variable AC supply. Okay, so we want to increase the voltage from 0 to 300 volt. Okay, then we go for this auto transformer. I will show you each and every hardware one by one when we move to the panel table. So first of all, understand this schematic diagram. Auto transformer is there. This is the variable R through which you can change the voltage from 0 to 300. To measure this voltmeter, we have a voltmeter which is ranging from 0 to 250 volt. Now we have to measure the input power also. For input power, we have an instrument called wattmeter. Okay, as you all know that power is measured in watt. So this instrument is called wattmeter. And it has 4 points, 4 terminals, M and C, L and a voltage point which is generally marked 0, generally marked 150 volt or 300 volt. Here, since we have to measure a voltage between 0 to 220 volt, therefore you are using a 0 to 300 volt point. Now this is the auto transformer. This is the schematic symbol of the transformer, the single phase transformer. So before proceeding to the experiment, you should know what is the rating of that transformer. So in our lab, we have this much of transformer of rating 1 kVA. This is the power rating. Okay, this is the power rating, and this is the voltage rating. As I already told you in theoretical class, that the first reading is always of the primary winding. That is 220 volt is the primary voltage, and this second reading 220 volt is the secondary voltage. No doubt, in practically you will find that primary and secondary voltage are different, but here in our laboratory we have a same voltage. This is called isolated transformer, and it is generally being used in our laboratories, small laboratories of the college level. But practically you generally have 11 by 440 volt or 440 volt by 11 or 330 kilovolt by 11 kilovolt, like this. The frequency at which operate is 50 Hz. As in India, we used to operate the AC devices at 50 Hz. Then we have a resistive load. Okay, a load is there which is variable in nature. The arrow sign indicates that this load is variable in nature, but it is resistive. It is not inductive, it is not capacitive, but it is resistive. And we are measuring this voltage across this load with the help of a voltmeter. Now this voltmeter is again of moving iron type. Mind it, you should know as an electrical engineer that which type of instrument you are using. For example, the voltmeter which we are using on the input side is again of moving iron type. Here we cannot use PMMC voltmeter. Please find out from your books or from your previous knowledge why we cannot use PMMC voltmeter here. Why we are using moving iron voltmeter only. So after drawing this diagram, we have to calculate certain two things. One is voltage regulation. How we define first of all voltage regulation? Voltage regulation is defined as difference between the no load voltage and the full load voltage. Now what happens? This is the transformer primary side and this is the secondary side. Suppose no load is present. No load means zero load. That is, you are connecting no load across this. Then there will be some voltage across these two terminals. That voltage is called no load voltage, and it will be the maximum voltage. Is it clear? So this is represented by E0. Okay. Now you connect a load which is of the highest rating. Highest rating means that is it will draw the rated current. So when a transformer secondary is drawing rated current, okay, it means it is at full load condition. Okay, now how to find out the rated current on the secondary side? For the simple, it is there. What is the maximum voltage on the secondary side? The maximum voltage is 220 volt. What is the power rating of this transformer? This is 1 kVA. That is, can also be written as 1000 volt ampere. So now with the help of these two data, you can find out the secondary rated current. The secondary rated current will be 1000, that is this reading divided by this secondary voltage 220 volt. So when you will calculate it, it comes out to be 4.454 ampere. Okay. So when this much of current flows through this resistor, when it is in loaded condition, then we call it as a full load condition. Now we measure the voltage across this full load through with the help of this voltmeter. If suppose it come out to be V, it will be always less than the no load voltage. This difference is called voltage regulation, and mathematically we define as E naught minus V upon V into 100. It is always calculated in percentage. That is, therefore, percentage voltage regulation. Lower this quantity is, better is your transformer. Higher this quantity is, your transformer is not good condition. For example, you got the voltage regulation of two transformers. One transformer is 10%, another is 20%. Then 10% is better in comparison to 20%. No doubt, this is the higher value, but it is poor from voltage regulation point of view. Second data we calculate is the efficiency. How to calculate the efficiency? Efficiency of any machine is defined as output power upon input power. Is it clear? This is defined for every machine, whether it is a mechanical, electrical, hydraulic or any type of machine. Efficiency is always defined as P out upon P in. P output, the output power, P in is the input power. So here also we have used the electrical power. Okay, so we measure with the help of wattmeter. So this wattmeter which is present on the primary side will measure P input, and this wattmeter which is present on the output secondary side will measure P out. So you just measure these two quantities and just find out the ratio of P out upon P in. You will get efficiency, and if I will multiply with 100, I will get percentage efficiency. So with this much of the background, practical background, now we will move to the panel to carry out the experiment. Dear students, now we have reached to the panel where we will be conducting this experiment to find out the voltage regulation and efficiency of a single phase transformer. So where is our transformer? You can see this is our single phase transformer. Okay, this is a 1 kVA transformer operating at 50 Hz. With on the primary side, the rated voltage is 220 volt, and on the secondary side the rated voltage is again 220 volt. You need not have to confuse. Just for sake to understand the basic concept of the transformer, the voltage ratings are being same, so that there is no danger to you. Okay, so what else we require? A transformer. As I have already told you in the circuit diagram that we will be requiring a variable AC supply. So this is the auto transformer. You can see this auto transformer, it is being fed through this panel where AC supply is coming. Okay, and here we are taking the two output terminals. Okay, so and with the help of this ring you can change the voltage from 0 to 300 voltage, but here the maximum voltage is 220 volt, so we can reach up to 220 volt. So by moving this ring we can get the variable AC voltage up to the rated voltage also. Then to measure this voltage, as you have seen in the diagram, that we have an voltmeter, moving iron voltmeter. Okay, again it is of rating of 0 to 250 volt, because the maximum voltage we have to apply is 220 volt. So we are using a 0 to 220 volt moving iron voltmeter to measure the voltage. Now we have to measure the input power also. So for input power we measure with the help of the wattmeter. You can see this is a wattmeter, okay, which can measure both AC and DC, because AC and DC are written on it, and it ranges from 0 to 750 watt. Okay, now you can see there are some connections are there. Okay, these connections are actually basically M and C. Okay, which you have seen in the schematic diagram. So these M and C are being short circuited as was shown in the diagram, and then we have a common terminal. This is the line voltage, and we have a 0 to 300 volt terminal. Okay, so these connections are being made. Okay, then they are being fed to the input of the transformer. You can see this condition. Now we have to take the output. So we have these two output terminals. Okay, these output terminals are being fed to the load through an wattmeter. This is an output wattmeter which measures the output power. Again, the connections are same as that of the input wattmeter. That is, the M and C are being short circuited. There is a common terminal is there. Then there is a line terminal is there. Then another terminal is there from which we fed it to the voltmeter. Okay, and this is the resistive load. Okay, as I have already told you that we have to put a resistive load on the secondary side. This is the resistive load. You can see the rheostats are being connected here. Okay, so by putting the switch in on condition, we can insert the resistance, and the maximum load in terms of current which can fed to this experiment is 5.45 ampere. So we will switch on only that much of the resistance which can bear a current of 4.54 ampere current. Dear student, now we are starting the experiment. The switch is made on, and now you can see we are increasing the input voltage with the help of this auto transformer. You know how much voltage increased? You can visualize through this voltmeter. Now, as I've already told you that we have to keep 220 volt, so you can see we have made an approximate voltage of 220 volt across this input terminals. We can visualize through voltmeter. Now, as we have increased the voltage, we can see some power is there on the power reading is there in the wattmeter. So we have to find out that reading also, and at present, zero reading is there on the output wattmeter because your load is off condition. You can see all the switches are in off condition. All the switches are in off condition. So this indicates that you are under no load condition. You are under no load condition. So no output power is there. Now we will find out the no load voltage. So input voltage was 220 volt, and now you can see with the help of this output voltmeter. Now how much reading is this? 220. It is approximately 220 volt. You can see approximately it is 220 volt. So the no load voltage is our 220 volt that we have to write down in our observation table. Now you can see this is the observation table. Okay, we have input voltage V1 is 220 volt. Input power, okay, we will calculate. We will observe from the that wattmeter. Output power also from the output power is 0 because it is operated at no load. Then output voltage is 220 volt, and output current is also 0 because it is under no load condition. So I can write down here. Power kitna? So you can see I am writing here 14 to 4. 220 volt is input power is 160 watt, output power is 0, and output voltage is again 220 volt, output current is 0 ampere. So this one reading is complete. Now I will increase the load. I am increasing the load. Now I will keep one eye over my ammeter. See, I will stop where the current will reach to 4.54 ampere, that is near about 4.5. Yeah, now you can see I have approximately reached to my rated secondary current, that is 4.54 ampere. Okay, so now you can see the load, some of the load. Now this load is on condition, this is also in on condition, this is on condition, this is on condition, this is also in on condition, and this is also in on condition. In fact, I have used 6 switches to get this 4.54 ampere current. Okay, so this is the full load condition. This condition is called full load condition. Now I will measure the voltage, the output voltage. So you can see the output voltage is approximately 210 volt. 210 volt. So you can see when it was under no load condition, the output voltage was 220 volt. But now when under full load condition, it is 220 volt. So this difference of 10 volt divided by the divided by the full load voltage, that is 210 volt, will give you the voltage regulation in percentage. So we have, you can see we have written down the readings. 220 volt input voltage, input power is 280 into 4, the output power is 250 into 4, 4 is the scale factor, multiplying factor, output voltage is 210, and output current is 4.5 ampere. It is 4.5 ampere current. Okay, so this reading we have got. Now we have to do the calculation, that is the percentage voltage regulation will be equal to nothing but how much? 220 minus 210 divided by 210 into 100. So you make this calculation, you will get voltage regulation. And now come percentage efficiency. Percentage efficiency is again at the full load condition. Okay, now this efficiency is full load condition. So how much is output? That is P out upon P in. P out is how much? 250 into 4, that is 1000 watt, and P input is nothing but 1120. So you can calculate this, multiply by 100, you will get the percentage efficiency. And you will surprised to know that transformer used to have efficiency between 98 to 99%. The losses are very minimum because it is a static device. Okay, so that's all about this experiment. Hope you have enjoyed it.